So in our week 3 lesson, we looked at the activity questions. Formulating your question, we worked with our partners in week 2 and we decided if our partner was fastest and who was most consistent. Now we used the online program Tuva Labs, and if you didn't do the online program Tuva Labs, you need to sign up to that. So when you click on the Tuva Labs sign up, you'll see a username or email and a password. You can just type in a username and then you can just type in your password. Or if you haven't registered, you'll need to sign up. You'll go into I'm a student and then type in your first name and then the initial of your last name. Do you have a class code? Yes, you have a class code. The class code is located in activity under week 1. And your class code is 648AJ. So just paste that in there. And then you can have your username and password and sign up. In this case, mine's already taken, so I can just log in. So once you log in, you should see the Tuva dashboard. You'll have a content library and an upload. So what I'd like you to do is take the data set from week 2 that you created with your group and then add into new data set. So in this case, there you go. Once you get into this screen, even though it says that I don't have any uploads remaining because you can have up to 5, you'll see a computer icon. You need to click on the computer icon and then upload your Excel file into your Tuva Labs. Once you've done that, you can go into My Datasets. You can go into Reaction Times. And you'll see all these little dots located on the screen. So this is just a scatter plot, but it doesn't have its variables in there. So you need to add in the variables. So we'll add in the reaction time into the Y attribute or the dependent variable. We'll arrive the reaction time into the x-axis or the independent variable. And we'll have the name in the y-axis. So in this one, I've got Drew, Finn, and Kira's, just as an example. Now, what I'd like you to do, so this is in a dot plot, I'd like you to go over into box plot with outliers, and that will show us our interquartile range. So if you hover over the box, you'll see box plot, your lower whisker and upper whisker, which indicates your range, your quartiles, so quartile 1 and 3, your median value, and the interquartile range, which is Q3 minus Q1. I'd then like you to go over into stats and go into mean, median, mode, and standard deviation, so highlighting all of those. And then you will have some lines appear. Now when you click on the lines and you hover over them, you'll see standard deviation of reaction time. And the standard deviation in Kira's is 0.736. And in Finn's, because it's a little bit more consistent, it'll be 0.366. And in Drew's, we've got even more consistency, so 0.264. And you'll see that they are all hovering around the mean and the median and the mode. Now, if you see a dot like this and it has your name attached to it, that's what is called an outlier, and it falls outside of the range of our expected data set. So if you have one of those, that will be affecting your standard deviation and your mean. So I'd like you to go through that and create that for me. And then once you've done that, you can hit save and then save it as reaction times. And that will be saved into your Tuva content library and my dataset. So if we go into my dataset, this part here is the graphs for your reaction times that you've created. I'll just get rid of the old one. All right, so that was part 1. Part 2 was going through the activity questions, and you can copy the activity questions into your individual OneNotes. And you have to go through the activity questions and answer the activity questions. So looking at your data, what is the most typical reaction time for you? So you'll need to use your mean, median, and mode, or your measures of central tendency to answer that question. You need to explain which of your central tendency values you chose, mean, median, and mode, and why you chose that value. And would you revise your prediction and then state why or why not? Looking at your data, would you say your reaction time was consistent? So you need to look at consistency, which is referring to your standard deviation value, and you need to state whether your data was more consistent or less consistent than your partner's. And do you think your reaction time is accurate for you? So do you think that your reaction times that you have presented is a good indication of your mean reaction time, your average reaction time? And question 8, did the mean or median represent the center of your data better? Which one was closer to the center of your data, and which one do you think was impacted by outliers? And how much was your data spread out? So you'll need to use all of your values there for that question. So that was the second part. Then we moved into week 2 knowledge. So we talked about statistical inference, or the process of estimating, forecasting, or making decisions based on data that you've drawn from your population. So a population is all of the items of interest to you as a statistical analyzer. It's frequently very large. A sample is a subset of our data drawn from the population. So the example is that there are 500 students at a school, but only 24 in a class. If I was looking at class grades, the population would be the 500 students, and then the sample I would take is the 24 from a single class. So in our next activity, we're going to be dealing with large data sets, which is the knowledge discovery and database processing, or the KDD for short. So it's actually processing large data or high-level applications of data and using a mining technique. It's an interest to researchers in machine learning, pattern recognition, statistics, artificial intelligence, and data visualization. So the steps in a KDD process. You develop an understanding on prior knowledge of the end goal. So what are you trying to find in the data? Create a data set, select a data set, or focus on a subset of variables from the large data set. You then need to clean and reprocess the data that you have. So you need to remove any outliers, collect any of the necessary information, and handle missing data by strategically removing it. So data reduction and projection, so finding useful features to represent the data depending on the goal of your task. So that's going back into our descriptive statistics and dealing with graphs. What graph is going to show or represent our data accurately to represent the goal? We need to reduce the effective number of variables under consideration, and you need to find an invariant representation for the data. So you need to find the best graph to suit that data. You need to choose the type of data mining task. So you're either choosing classification, which will be dealing with bar graphs and charts and pie charts, clustering, which will deal with dot plots or scatter plots, or correlation, which might be dealing with line graphs. So 6 is choosing the appropriate measure of central tendency or variability. So we're selecting methods to be used for searching patterns in our data. And we need to decide which model or parameters are going to be appropriate. Then data mining, which is searching for patterns of interest and representing and classifying them using rules or graphs. You then need to interpret patterns using your inferential statistical understanding. So what can you infer? What can you understand about that data? You then need to consolidate your discovered knowledge. And then this is the figure just below is just showing you the full 9 steps in one diagram. Now the activity, your tasks. So we actually have the data from the Census of Schools for 2014 questionnaire. So you need to critically analyse that data sample to describe the life of a typical student in 2014 using statistical techniques. In your groups, you're going to create a secondary data set for the life of a student in 2019 using your own responses to the questions. You'll then need to compare the two data sets and create a persuasive argument in response to the question, have students' lives changed in the last 5 years? So you've been given an Excel spreadsheet which displays all answers for 812 students who participated in 2014. The original student questionnaire for you to view and add your own answers to the bottom of the Excel spreadsheet. You have access to Tuva to find single participants, and you have steps for dealing with large data sets in your OneNote, so the KDD process that we saw before. So to download the Excel document, what I'd like you to do is double click, and then it will say, we can't open this file from OneNote online, would you like to download a copy? Click download. And I'd also like you to download the student questionnaire. And then we'll move on to the creating a persuasive argument using data in next week's topic. Now, I'm going to finish off here and then I'll move into part 2, which was 3. So 3 was the final part of our questionnaire, but I need to finish it, otherwise I won't be able to record over changing screens to Excel.